I have a question real quick. When will the test be available?
Sometime today.
Okay, so when is it due?
Just like everything else, before the semester is out,
Oh,
December
okay,
2nd or 9th.
okay.
All right. Good afternoon, everyone. Good afternoon. Hope everybody's doing all right. Wait for everybody else to get in before we get started. All right. Looks like everybody's in. Okay. So once again, good afternoon. Hope everybody's doing great. Everybody's doing all right. If you look in Math Lab, the test review is posted. The test I will be posting before the end of the day. At least that's the goal anyway. And then you'll have access to it, to knock it out at your earliest convenience. So today we're looking at 7.1 and 7.2. And as you can see, 7.1 is seeking correlation. So correlation is this between two variables. When the higher values of one variable are consistently associated with the higher values of another, or higher values of one variable are consistently associated with lower values of another. Let me know if I scroll it too far. So next we're looking at scatter plot. Scatter plot is a graph that shows the relationship between two quantitative variables measured on the same individual. Each individual in the data set is represented by a point. All right, anybody holding on to the dark blue? All right, so in order to graph these points, we're going to have an explanatory variable and a response variable. So here's just a comparison between the two, the difference between the explanatory and response variable. So the explanatory variable explains the value of the response variable, and the response variable is explained by the explanatory variable. In other words, it responds to the explanatory variable. So I'll give you an example of that, when we get a little further down. If you remember your XY chart, XY graphing, your explanatory variable is your X variable, your response will be your Y. That's your domain versus your range, input versus output, independent versus dependent variables, horizontal axis versus your vertical, and then your predictor and the predicted. So if there's anything you're trying to predict, that has to be a response variable. Well, I would say has to be. Normally, that's your response variable. I'll say it like that. I'll scroll up. Oh, and here's just a generic representation of what our scatter plot would look like. We would have numbers and points that would actually graph these dots, numbers and values that would actually graph these points. But your horizontal axis is your explanatory, vertical axis is your response. And notice when you talk about your XY Cartesian coordinate plane, we're only using the first quadrant. We're only using the first quadrant. All right, can I scroll up? Is everybody done copying? Everybody done? All right. So linear relations or correlations. When a line best sums up the shape of the scatter plot, we call it linear. When you look at the word linear, line is the key word there. So when a line best sums up the shape of the scatter plot, that's what we're talking about here as a linear relation or linear correlation. So the first two are examples of a linear relationship. The next two are nonlinear. So just because it doesn't have a pattern doesn't mean that just because it's not linear doesn't mean that it doesn't have a pattern. So sometimes there is a pattern there, it's just not a linear pattern. And then this is considered no relation at all. All right, can I scroll up? Oh, and that purple statement is non-linear does not mean no relation, just no linear relation. So that was what I mentioned earlier. All right, so types of correlation. Positive correlation is when both variables tend to increase together. So in other words, when you're reading your graph from left to right, it goes up. Negative correlation, the two variables tend to change in opposite directions. So when one is increasing, the other is decreasing. So in other words, when you read it from left to right, your pattern will go down. All right, scrolling up. So last two statements similar to what we've already discussed. With no correlation, there is no apparent relationship between the two variables. And then nonlinear relationship, the two patterns or the two variables are related, but the relationship results in a scatter plot that does not follow a straight line pattern. Scroll up. All right, so next we're looking at linear correlation, coefficient, and the different properties of it. So we talked about these relationships and the associations, but the linear correlation coefficient actually puts a number on what we're talking about. So it's a measure of strength and direction of the linear relationship between the two quantities or two quantitative variables. All right, hold on to the green. All right. So Greek letter rho is what they use for the population correlation coefficient. We're going to use R, just our regular R for the sample correlation coefficient. All right. So you guys aren't going to be held responsible for knowing the formula or knowing how to calculate the formula, but you do need to have something, some type of technology that will enable you to be able to calculate it comfortably and accurately. So that's why I say find a calculator, website, or app or something along those lines that will calculate the correlation coefficient and the regression line. Talking about the correlation coefficient right now, regression line we'll talk about later. Easycalculation.com is one that I know is reliable, and I'll show you that one, but you don't have to use that. You can use anything just like not asking you to pay for anything. You know, there's a whole bunch of free stuff out there. But you want something that can calculate the correlation coefficient and the regression line uh, accurately. Let's scroll up. All right, so let's look at some properties of the correlation coefficient. It's between -1 and 1 inclusive, so that means it can be equal to either -1 or +1. If R is equal to +1, then a perfect positive linear relation exists. As R is equal to -1, then a perfect negative linear relation exists. All right. So the closer R is to +1, the stronger the evidence of a positive association. The closer R is to -1, the stronger the evidence of a negative association. All right, scroll up. So if R is close to zero, then little or no evidence exists of a linear relation. So R being close to zero does not imply no relation, just no linear relation. It goes back to what we were saying before. It is possible for you to have a type of relation or relationship with your pattern, just that it does not have to be linear. And so that's what this helps us to find linear relationships. And the last two, it is a unitless measure of association, and it is not resistant. I mean, it is affected by outliers. All right, scrolling up. So the next few are just examples of scatter plots and what your correlation coefficient would be. Like for example, looking at that first one, remember we said R being equal to +1 is a straight perfect line going up. So and then as we deviate from that, then our number goes away from 1 and closer to 0, and there's more spread in our points, or spread in our data. So here we have a straight line that's R equal to 1, but then here we have a little bit more spread, so that's 0.9. And this is just me guesstimating. We're just showing you the effects of moving closer to 0 and what that means for us. And then even more spread going to 0.4. We see that there's still a pattern going increasing pattern, but it's not as close to having that perfect line, as 0.9 would be. And then the same thing happens when you're looking at a negative number. Our perfect line is -1. And then as we deviate away from that -1, we start to get more spread in our data. Here, R will be close to 0, even though there is an arc here, but it's not a line. So R will be close to 0. And then this, no pattern at all, will be close to 0 as well. All right, I'm good. Let's scroll up. All right. So here, looking at finding the correlation coefficient between the club head speed and the distance. So what we have here is we have a golfer. Club head speed is how fast he is swinging his golf club or how hard he's swinging his golf club. And then the distance the ball travel once he actually hits the ball. So our explanatory variable is the club head speed. It explains how far the ball is going to travel once hit. The response variable is the distance the ball travel. It responds to how fast he's swinging his golf club, or in other words, how hard he's hitting the ball. So that's an example of explanatory variable versus your response variable. Once again, your distance the ball travel responds to how hard or how fast he's swinging the golf club, and your explanatory variable, your golf club head speed explains why the ball will travel, further than other times. All right. Values up. So can I go to the next page so I can show you guys the rest of the copy? All right. So just give you an idea of how you do it. If you go to Google and just type in correlation coefficient easy calculator. So the first one that should pop up is this is easycalculation.com correlation coefficient. And like I said before, you don't necessarily have to use easycalculation.com. I just know that it works for the most part. And so you can add rows and take them away. 1, 2, 3, 4, 5, 6, 7, 8. So then you put in your values accordingly. All right, so typing in your values, that should be 264. And you most definitely want to make sure you check your values, make sure they are correct. And so this is what we have. And the reason why you most definitely want to make sure they're correct. If I were to go for 275 and they put 274, it changes my value completely. So just being one digit off this number, no matter where it is, it goes from 94 to 3. I'll put this back. Now it's back at 93.86. So just make sure that you put in your data values correctly and you should be fine. So questions on this before I go back to the notes? All right. And so find the correlation coefficient by using technology. We got 0.939. And of course, MATLAB will let you know how many decimal places they want. So before we touch on 7.2, any questions on anything I've written up to this point? All right. So 7.2 is light, gives you a few things to touch on and pertaining to the, and they only had about 6 questions in there, but talk about the effects of outliers, and then the last thing talked about causality. So let's look at a few things in 7.2 and then call it a day. Mhm. So interpreting correlation. So the first thing you talk about is effect of outliers. Effects of outliers. Outliers are very extreme values in comparison to the data set. So they can be very, very large or very, very small. Remember, outliers are important to examine because remember we talked about, or we mentioned that your correlation coefficient is not, what's the term? Not exempt, not resistant. There we go. Correlation coefficient is not resistant. So that means outliers do affect your correlation coefficient. So you must examine outliers and their effects carefully before interpreting correlation. Chance to write those. Get that last one. Yep. If outliers are a mistake, they can produce correlations that are not real or mask the presence of real correlations. All right. If outliers are correct, they may be telling us about relationships that would otherwise be difficult to see. And once again, that's because since they're extreme values, they can change your correlation coefficient. So sometimes, you may want to run the data with the outlier and then run it without the outliers and see how they change the information and what conclusions you will come to when it comes to your correlation, the outliers in existence of your data set. Can I scroll up? Anybody holding on to blue before I go all the way up? No? So the last thing out of this section, correlation does not imply causality or causation. Says do not conclude that a cause and effect relationship between two variables exists just because there is correlation, no matter how close to +1 or -1 the correlation may be. All right, can you scroll up? So, example, a politician wants to close down liquor stores in the city because there was a positive correlation between the number of liquor stores in the neighborhood and the amount of crime. All right, so even a correlation near positive one is not enough to conclude that changing one variable, liquor stores, will lead to a change in other variable, crime. So in other words, there may be other things in play that will actually lead to the crime versus just closing down liquor stores. So looking into what is the gang activity like in that area, um, how many shopping centers, because some shopping centers warrant a certain amount of activity. Um, Sometimes low level income, not low level income, but low level income housing. Yeah, sometimes attract a certain level of activity or certain types of activity. So there are different things that could be in play that can cause things that lead towards crime, and liquor stores may not be the factor, or may not be the only factor, maybe multiple factors that would lead towards high crime. So you cannot say that just because there's a positive correlation between liquor stores and crime, that if you cut out one, then the other one will not rise. But what this does for us is that it puts us in a direction for us to investigate. So, it points you in the direction of looking at liquor stores to see if that's something that we can pull out to cause crime to go down and stuff like that. So it points you into the direction, but you cannot conclude just by the correlation. You need the correlation and other information in order to say that there's actually causation. All right, anybody holding on to green? So then we have three possible explanations for the correlation, or a correlation. All right. First one is that the correlation may be a coincidence. It's maybe that um yeah, just something that just happened. The numbers just lined up correctly. So coincidence is possible. Anybody holding on to the red? It's possible that both correlated variables might be directly influenced by some common underlying cause. You go back to the crime in the liquor store example. It could be that there's a high gang activity in that area, two rival gangs in that area that's causing, the correlation between the two. And it just so happened that the liquor stores are there, crime is there, and all this stuff. And then the last one of the correlated variables may actually be a cause of the other. And notice it says a cause, not the cause. So even in this case, it may be one of several causes. So it goes back to what I was saying initially, that liquor stores could be attracting that type of activity, but there may be multiple reasons as to why crime is high in that area. All right. Questions. That's it for 7-2. Anybody have any questions or anything before we close out today? That's 7172. Next class we'll look at 7374. And as always, have the opportunity for you guys to ask whatever questions you want. Yep. So I have somebody asked about something for 6.3. You can go ahead and type that whatever question that is that you were asking about as well. And then I'll go ahead and knock that out. So if you want to stay back for that question, feel free to do so. If not, these are all notes that we're doing today. You guys have a great weekend. Be safe, and I'll see you on Monday. All right, thanks. You have a good one. Yep, y'all take care. Let's see, it was number. I go by number. Okay, let me pull it up. All right, is the one about the roulette wheel? Make sure we're talking about the same one. All right, cool. Okay, so we have a roulette wheel. We have 38 numbers, 18 odd, 18 even, also black, these are red, 0 and double 0. That's $16. Oh, this is expected value. Oh, okay. I hadn't read. I thought it was a probability, just a straight probability one. All right, so we have to do. Okay, so we have bet $16. $16 on odd. The probability of losing $16 is 20. Losing is 20 to 38. Probably a winning is where it go, 1838. Right, okay. All right, so they want to know the 16 outcome, expected value. Okay, so we should be multiplying. We talk about losing, that's going to be negative. Winning is going to be positive. And let me see the notation so I can write it better. Oh, that's all good. Okay. Expected value is going to be 16. Was negative 16 times 20 over 38 plus positive 16 times 18 over 38. So once again, losing, the probability is 20 over 38. Winning, the probability was 18 over 38. Let's see, bet 16. I'm trying to make sure that notes to it. Okay. Divided by 38 times 16. It's going to be negative 842. Divided by 38 times 16. There's 758. Negative 0.84. We're not rounded. No, 4. 8. All right, let's see if that's the value they're looking for. Yep, that's A. Okay, if the best option for to bet $16 on odd or not to bet, why choose the value? Just showing y'all know if you got to B yet, but that's what we have now. Is the best option to bet $16 odd or not to bet? And it says why I choose the correct answer. So betting on odd is the best because it has the highest expected value. Not betting is best because they have the highest expected value. Those $16 on odd is best despite having lower expected value and not betting 16 on odd. Not betting is best despite having lower. I think not betting is best because not betting would be 0. Let's see if I'm right. Yep. So not betting is 0. Betting is negative 84 cents. So the best option is not to bet because you're not going to lose anything. 0 is still greater than negative 84 cents, but you're expected to lose at least negative 84 cents every time you bet $16. So that's how you would do it. Questions on that? All right, no problem. All right, so you have a good one.